Alright, ladies and gentlemen, welcome back to another unit here at SPCPA. This unit we're going to be looking at trigonometry. Now this is the first time you're going to see trigonometry, but it's not going to be the last for sure. You're going to see trigonometry in Algebra 2, you're going to see it in pre-calc, you're going to see it in calc, applied math, discrete, you're going to see it a lot of places. So this is the first time that we really see trigonometry in your math career, though. A few notes to you. You will need a scientific or graphing calculator for this unit. Particularly, you need some sort of calculator that has these buttons, the sin, cos, and tan button here. Those are going to be critical for you to have. If your calculator does not have those buttons, please get a calculator that does. It might say trig, but as long as it has a trig, sine, cosine, tangent button, you should be all right. If you are using a graphing calculator like the TI-83 that I have here, a TI-84, 85, whatever you're using, if you hit the mode button up top, please make sure if you scroll down that you are in degree mode. That's going to be really important. If you're in radian mode, you're going to get some weird answers. A way to check which mode you're in case you're using a cell phone calculator or something. If you go ahead and type sine of 45 degrees, if you're in the correct mode, you should get a 0.707 something. What is it? 0.7071. And it keeps on going. If you're in the wrong mode, like if I switch back to radian mode and then try that calculation again, that's going to give me the wrong answer. Try to get into degree mode if at all possible. Otherwise, you really can't do the problems today. Anywho, let's make sure I'm in the right mode. Here we go, and let's begin. Goals for today. You're going to be able to identify the opposite, adjacent, and hypotenuse in a right triangle. You're going to be able to identify which trigonometric ratio is appropriate for any given trig problem. And you're going to be able to use trigonometry to find missing sides of right triangles. You already know how to identify a few pieces of a right triangle. In this right triangle, obviously the red box indicates that it's a right angle. We know that the side opposite that red box, so given this angle, this side opposite is going to be the hypotenuse. That's the longest side. I'm going to go ahead and write that down here. Side SR is the hypotenuse of this triangle. The next couple of terms we're going to use are opposite and adjacent. Please remember in Chapter 1, adjacent stood for next to. It's something that's right by another thing. So, and then opposite just means opposite. So if you look at angle S, for example, angle S right here, the opposite side of angle S is this side over here because it's as far away from S as you can get. S also doesn't touch it. S touches these two sides, this one and this one, but it does not touch the side RT. So we'd say the side opposite S is RT. The side adjacent to S, now there are two sides that are adjacent to S. The hypotenuse is adjacent because it's touching it, and then this bottom side, ST, is also adjacent. In trigonometry, we say that the adjacent side is the one that touches the angle, but is not the hypotenuse. So in this example here, side ST we would say is adjacent to angle S. One way to think about it, if you were to put your thumb right here over the angle, whichever two sides you're touching are adjacent to that angle, the one that's not the hypotenuse we call the adjacent side then. Last couple of sides here, I notice for these next couple of problems, we're dealing with angle R. I'm going to highlight that in blue. Angle R up here. Our hypotenuse stays the same. The hypotenuse is always alongside, but opposites and adjacents change. Our opposite side here now is going to be this side on the bottom, ST, and our adjacent side is going to be the side that touches angle R, so RT. The two just changed places. So, opposite and adjacent, it depends on which angle you're referring to at first as to which side is opposite versus adjacent. I'm going to show a few practice ones here. If you'd like to practice on your own, feel free to pause the YouTube video, guess which side is the one I'm talking about, and then you can see the answer. For example, with this triangle, if you want to identify the side opposite A, take a moment to pause the YouTube video and guess. Very good. Hopefully you guessed that the side opposite is CB. This side down at the bottom is opposite angle A because it's as far away as you can get from angle A. The side adjacent to angle A, remember there are two sides adjacent to angle A. One's the hypotenuse, so we don't count that one. AC is the side that's adjacent to angle A. The side opposite B is also AC. Sometimes triangles are upside down, that's fine. In this triangle, remember the hypotenuse is always a long side, so KL is going to be our hypotenuse. Or you could also say LK. The side opposite L is KJ, because angle L is down here. KJ is up here, as far away as you can get from L. It's opposite. And the side that's adjacent to K, we need a side that's adjacent to K here. Well, these two sides touch K. This is already the hypotenuse, so it'd be this side up top that's our adjacent side. That'd be KJ is our adjacent side. There are three trigonometric ratios. As you saw on the calculator, sine, cosine, and tangent, there are three big trigonometric ratios. There are actually 6 that you're going to see throughout your math career. We'll see 3 in geometry and 3 in algebra 2, and you'll probably see the 3 others in pre-calculus. The first one we're going to talk about is sine. Remember that a ratio is just a fraction. Sine, if you go ahead and write it out as a fraction, sine is equal to, let's see if I can get my pointer out, sine is equal to the opposite side divided by the hypotenuse. I wish I could type smaller. I can't. Oh well. Cosine now, cosine is going to be the adjacent divided by the hypotenuse. And then the tangent function, I'm just going to go ahead and write that in green and write a little division sign. Tangent is going to be opposite divided by adjacent. Alright, so each of them are fractions. The memory device that we use that you're going to see pretty frequently throughout your career here is SO. Then I'll switch over to red, Ka, and switching over to green, TOA. SOHCAHTOA, TOA. This stands for sine is going to be opposite divided by hypotenuse, SOH. Cosine is adjacent over hypotenuse, CAH. And tangent is opposite over adjacent, TOA. We can use this to draw a few trigonometric ratios. Before you do any of these problems, please, please, please write down SOHCAHTOA on your paper. That's really going to help you out. For this first one, sine. Sine of R, identify angle R. Once we have angle R, let's go and label our sides. This top side's the hypotenuse because it's the long side. Opposite angle R is the bottom one. The side that's 12 in length is opposite. And the adjacent side is this side that touches R, doesn't touch the others. If we want to write the sine of angle R, sine of angle R, remember sine is opposite over hypotenuse, so I'm going to take my opposite side, 12, and divide that by my hypotenuse, 13. Same thing with cosine. Cosine is adjacent over hypotenuse, CAH, adjacent over hypotenuse, so I'm going to go ahead and just write 5 divided by 13. Now for the next couple of problems, you might notice something different. Rather than concentrating on angle R here, these are concentrating on angle S. If we concentrate on angle S, the sides that we're referring to, hypotenuse doesn't change, but opposite and adjacent trade places. The opposite side is now the 5, the adjacent side is now the 12, because we're concentrating on angle R S instead of angle R. If we want to go ahead and write those out, we can certainly do that. Cosine of angle S, remember cosine is the ka part of SOHCAHTOA, adjacent over hypotenuse, that'd be 12 over 13, adjacent over hypotenuse. And tangent of S, remember up top here we have opposite now. Down on the bottom we have adjacent. Tangent has to do with, that's TOA, tangent has to do with opposite over adjacent. So I'm going to go and write 5 over 12. Now you might be asking, how is this going to be used in real life? We're just writing a bunch of fractions, Mr. Reece. Well, let's check it out. If we know an angle and we know a side length, like AB is 6.1 and an angle is 41 degrees. If we know those two pieces, we can find every single other side length using trigonometry. Keep in mind, we know angle A. That means that the side that we want to know, CB up here, that is the opposite side. It's the one that's far away from our angle that we have. The one that we do know is our adjacent side. Ask yourself, what side do we know, adjacent? What side do we want to know, opposite? And then using SOHCAHTOA, identify, well, opposites and adjacents, which trig function is going to help us out? It looks like with opposites and adjacents, it's the TOA one that has opposites and adjacents. So we're going to go ahead and, sorry about that, let's go rewrite that, opposite on the bottom here, adjacent. We're going to go ahead and write tangent of our angle, 41 degrees, is equal to our opposite side. We don't know how big it is yet. That's just side CB. We don't know how big it is. Over our adjacent side, 6.1. Using our calculator now, if we go ahead and type into our calculators tangent of 41 degrees, we're going to get 0.869. Let's remember that, 0.869. 0.869. Wish I could keep what I wrote, 0.869. So tangent of 41 degrees is equal to an unknown, that's CB side, over 6.1. And I believe that answer when we typed tan 41 into our calculators was 0.869 is equal to CB over 6.1. If we go and multiply both sides by 6.1 now, 0.869 times 6.1, I'm going to go and multiply this by 6.1. That leaves us with a total length of 5.3. That means that this side over here is 5.3 in length. You can do a similar thing when you're looking at example 2 now. You're going to be using, instead for example 2, if we need to know this side up here, we need to know the hypotenuse side this time around. And you know the adjacent side still. You know adjacent side, you need to know hypotenuse. Let's get rid of that. No good, my computer's freezing up. Here we go. We know the adjacent side, we need to know the hypotenuse side. Adjacent hypotenuse, you're going to use cosine. For this very last problem here, our triangle's upside down, but we'll go through it pretty quickly here. Do notice that our triangle's upside down, our hypotenuse is now on the bottom. And relative to the angle that we know, if we want to know SU, this distance over here, that's the opposite side. Opposite hypotenuse, remember we need to use sine. So we'll use sine of 42 degrees is equal to our opposite side. We don't know how big it is yet, so we'll just label it SU, over our hypotenuse, 9.5. I'm going to go ahead and use a calculator off screen just because that calculator keeps on clearing what I have. So taking the sine of 42 degrees, 42 sine of that gives us a 0.669. That means that sine of 42 degrees, 0.669, is equal to SU divided by 9.5. From here, You can either multiply both sides by 9.5, or if you want to do some cross multiplying, you can put this value over 1 and cross multiply. In either case, on one side as you're cross multiplying, SU times 1 is just SU, and on the other side, 9.5 times the 0.669 is going to round up to 6.36 or so, 6.36. That leaves this side over here to be 6.36, which seems entirely reasonable. If this whole distance here is 9.5, then this distance here, it seems reasonable that it's a 6.36. As always, email me if you have questions. The assignment has been posted on Moodle. Have a delightful day.